In this question, again he is asking about the diffraction pattern for a small pinhole, but here he has considered a monochromatic light in place of sunlight as in earlier problem 10.7. Now he is saying that as the size of the hole is increased, as the size of the hole of means the size of the pinhole is increased, so what is the effect on the diffraction pattern? So the analysis of this diffraction pattern for the circular aperture is quite complex, and following the analysis of the Fraunhofer diffraction, experimentally we can achieve this kind of diffraction pattern for a given monochromatic light, and its analysis is quite complex, and the analysis shows that the circular aperture, for this diffraction pattern of the circular aperture, the first minimum here, this is the central illuminated spot, and then there is a first minimum. The position of this first minimum is given by this formula sin theta equal to 1.22 lambda by d. So using this mathematical result, we can explain or solve this question. Now in this question he is saying that as the size of the hole is increased, so the size of the hole is d, and if we increase d for a given lambda, so we can say that if we increase d, the net value decreases. When the net value decreases, so correspondingly theta will be less. So theta is less means this diffraction pattern will get reduced, or these, you can say, rings will come closer, or the size of the diffraction pattern will decrease. So we can say that the size of the diffraction pattern will decrease. Clear? Now with the increase in the size of the aperture, more light is able to enter through the aperture. So more light means more energy is able to pass through, and hence the intensity of the pattern will increase. So we can say that option B is also correct, and obviously option C and D are wrong. So we have only two options correct, option A and